Hi all. This is Deepak Misal here. So today our topic is we are going to discuss the different path attributes in BGP and how you can configure those path attributes in Cisco ACI. Okay, so before we quickly jump on the lab, we will discuss a brief session about what are the different path attributes types and what are the different attributes. Okay, so what are the path attributes? So path attributes in BGP is a component within the BGP update message. So meaning is that whenever you have a neighborship between two devices, so let's suppose I have R1 and R2. There are two routers here. So irrespective of it's a eBGP neighborship, meaning they are different autonomous system, or if it is a IBGP neighborship, meaning they are in the same autonomous system. So if they have a BGP neighborship, so they will share some update of the prefixes that I have learned. If in order to reach to this network, you can reach via me. So R1 will send some update to the R2. So in that BGP update message, we will have attributes. Okay, so by using those attributes, what we can do a best path selection. So let's suppose you have your ACI fabric here, right? This is the ACI fabric, and there are two ISP connected to the ACI fabric. So you want ISP1 prefer over the ISP2. So then in that case, you can manipulate the BGP path selection by using those attributes. Okay, loop prevention, you can use those attributes in the loop prevention. Similarly, prefix classification for further processing. So it means you can add some tag to the prefixes and you can use them for further processing and information. So some information that you need to derive from those attributes. So that also you can um, uh, use those path attributes. Okay, so what are the different types of path attributes? So those are the well-known mandatory. Well-known mandatory meaning is that if there's a BGP neighborship, those whenever there is update message, so those attributes is mandatory. If that is not mandatory, R2 or R1 gonna drop it because that attribute must be in the BGP update. So meaning is like AS path, origin code, and the next hop. So those are the well-known mandatory path attributes. A well-known discretionary meaning is that R1 may or may not recognize that attribute. So if R2 is advertising some update to the R1, so R1 may or may not recognize that path attributes. One of the example is local preference is the one of the attributes. Optional transitive, this is optional and this is transitive. So meaning is that it is optional attribute. It's not like it will be always present in the BGP update, but if you configure it, then it will be. And transitive meaning is that it will basically go from hop by hop. So meaning is R1 is one part of one autonomous system, R2 is another autonomous system, and R3 is another autonomous system. So if you are distributing some BGP update, update to R2, and in that if you have some optional attribute, optional transitive attribute, so R1 will update to R2 and R2 update to the R3, right? And option non-transitive meaning is that R1 updated to R2, when R2 updating to R3, it will that attribute will not be present into that BGP update. So MED is the one, must be familiar with that. MED is the one attribute which is non-transitive, and the originator ID is also the other attribute. So we will discuss what are the different types of path uh, attribute and the best path algorithm. Okay, so the path attribute start with the next hop. It should be reachable, meaning is that R1 when R1 is updating to R2, some update about the prefix from R2. That next hop R1 should be reachable. If that is not reachable, I will not install that routing or prefix update into my BGP table. Okay, so the next will be wait, right? Bigger values preferred. So meaning is that whenever weight is another is a Cisco proprietary. So if R1 is updating to R2, R1 is updating to R2, so R2 will put some weight saying that so let's suppose there are two networks. Let's draw the topology. Okay, so there is a R2 router here, and let's suppose it is connected to the ISP2 and it is connected to the ISP1. right? So uh, now both are advertising to me the same prefix. So prefix meaning is some routes 10.0.0.0/8, let's suppose, and it's also advertising 10.0.0.0/8. Okay, so let's suppose this is the Cisco router, Cisco device. So I want to prefer that any internal traffic which is going to 10.0.0 always prefer ISP1 over the ISP2 for some reason, right? So what I'll do, I'll put them weight inside that. So meaning is that whenever I receive some update from ISP1, I'll put more weight than the ISP2, and so that will give more preference to the ISP1 router. Okay. Next is local preference. Is bigger is preferred, the same thing. I'll add more local preference here, and it will give more preference to ISP1. Now one is locally originated routes. Locally originated routes meaning is that if R2, let's suppose it's running some OSPF or some EHRP protocol, so I am putting those OSPF into the redistributing those into the BGP. So I'll prefer those routes over the other one. Okay, so this is well known, famous is a AS path length. Smaller length is prefer. So meaning is that if this is well known, well known mandatory attribute, right? AS path. So meaning is it's the same example. Let's say it's R2 router here, ISP1 here, right? And this is ISP2 here. Okay. Now let's suppose ISP has the AS number 1, ISP2 has AS number 2. Now let's suppose it's advertising some routes, it's the same route 10.0.0.8 ISP1, and ISP2 is also advertising 10.0.0.2. So while advertising that route, what I'll do, ISP1 will put its AS number with that prefix. Now, if ISP1 is connected some internally with some other ISP, let's suppose ISP number 3. Now its AS number is 3, right? So it meaning is that, and that route on ISP1, ISP3 is advertising it. So that 10.0.0.0/8, right? So it will be first the autonomous system 3 will come first, then the autonomous system 1 will come. So I know that 10.0 route originated from autonomous system number 3, then autonomous system number 1. Now it will reach to the R2. So R2 knows, okay, 10.0.0.8 has come from autonomous system 3 and autonomous system number 1. Now let's suppose the same route 10.0.0.2 or prefix ISP2 is advertising, but with only one hop, which is ISP number 2, right? So I will prefer the ISP number 2 route over the ISP um, 1, right? But for some case, if you want to prefer the ISP1 over the ISP2, so what you can do, you can use the weight local preference, or what you can do, you can prepend the AS number here. So meaning is that you can say that whenever the ISP2 is advertising some prefix to me, I'll put some more AS number while receiving the route. So I'll say 2 multiple times. I'll put 2 So I'll put 4 autonomous system when I'm receiving any route from the ISP2. So router 2 will prefer the um, ISP1 because it has the smaller length preferred, right? Now, the next one is origin preferred is E, or this question mark, right? So I is IGP, is EGP, and this one is incomplete. It's called incomplete. So meaning is that when the same thing ISP1, let's suppose ISP1, this is ISP2. So guys, I'm trying to explain you with a uh, very simple example, but we will see later in the ACI how you can configure these all parameters. Okay. So meaning is that now ISP1, ISP2, they are advertising the same 10.0.0.0/8. Okay. Now, if you are using a network command to distribute this 10.0.0.8 on the ISP1, so I'll put that I in front of that. Okay, now if I'm redistributing that route into the BGP, so let's suppose that 10.0.0.8 you're running from the OSPF, and then you are redistributing inside the BGP using a redistribute command. Okay, redistribute command. Then I'll put a incomplete here. So I'll give more preference to the network command over the redistribution command. So E we don't use it. It was used in very old age. Nowadays we don't use that EGP. So you will mostly see I and question mark. So whenever you redistribute the route in the BGP using redistribute command, you will see the question mark. So in ACI you will see lot of incomplete origin prefer or origin thing, right? Why you will see most of question mark thing in the BGP, or sorry, in the ACI. So that we will discuss when we will do the lab part. Okay, so that's a very important parameters in the BGP path attribute. Now, the next is a type of in the path attributes MED. MED is smaller is preferred, and as I said earlier, it's a non-transitive, right? So, meaning is that whenever you configure something MED, it will be there till the router two. Router two will not distribute um, inside the is AS path. Okay. Now neighbor type, I will prefer eBGP over IBGP. Then IGP metric to the next hop, smaller value is preferred. So right. So then these oldest, longest known eBGP route, lowest neighbor BGP ID, lowest. So mostly, you will see we will use only this one. Next hop, wait, local preference, local origin AS path. Most of the routes you will see it matches with either the local preference or with the AS path or with the origin preference. So you hardly go till the lowest neighbor IP address, but it's good to know the BGP best path algorithm. So this is the best path algorithm metric. So meaning is that I'll check first next hop is reachable, then I'll check wait is configured or not, then I will check local preference, then I will check local originate route, AS path, origin prefer. So like that I'll continue to go till the lowest neighbor IP address. Okay. Now, if all are matches, then it means both the paths are equal. So uh, I'll install both, and one will be my backup path. Okay, so let's quickly jump in the lab. So I'll put some more detailed diagram here. So that's the lab we're gonna work on. So let me explain you the topology here. It's very simple. It's not that um, it's not difficult to understand. So I have leaf 3, leaf 4 forming VPC, eBGP. Sorry, I need to take this one, right? Forming a eBGP neighborship with the Nexus host Nexus 9K2. So that's my switch here. Okay, that's my switch here. So it's a eBGP neighborship. Okay, and this one is also it's a sorry, from leaf 5 to Nexus 9K host 1. It's also the eBGP neighborship. Okay, and that's the OSPF neighborship between leaf 6 and the host 1 switch in the VLAN 104. Okay, so I have one server which is inside which is connected to the leaf 3. The server 1 IP address is 1.1.1.1.1. So what basically what I'm gonna do is I'm going to explain you the BGP path attributes. So for that, what I have done, so you see this 30.30.30/32. So meaning this eBGP neighborship, which is in autonomous 65002, is distributing that route over the eBGP to the leaf 3 and leaf 4. And similarly, this 30.30. So I'm basically redistributing or distributing the same route or prefix via two different autonomous systems. So this is 65003, this is 65002. So you can say it's ISP1, ISP1, you can say this is ISP2. Okay, this is ISP2. Now both are advertising this 30.30. So let's see in the lab what we have. Okay, what we have. Let me close this one. Yeah. Okay, so that is my leaf 3. So I'm right now in the leaf 3 where it is. Yeah. Okay, so I'm right now on leaf 3. on this leaf. Okay, so what I'm going to check now, yeah, so I have one what I'm seeing what are the routes that is coming on the BGP. So this 30.30.30/32, I'm receiving it from 10.0.32.71. So what is that 32.71? Is this one, right? So meaning is that this host is advertising to both the eBGP neighbor, which is leaf 3 and leaf 4. Now leaf 4 is advertising back to me leaf 3. So saying if you want to reach to 30 to 30, I have the path via me. But if you see here, 65004, 65002, and then there is the that's I flag, right? So the I flag is IGP. So meaning is that this route, this 30.30.30 is advertised using the network command. So how we can see it? We can see here. Um, Let me log in. Show run. Yeah, so you see here 30.30.30/32. I am distributing via network command. So that's what I can see here. Right now it's coming from 65002, then 65004. Now let's go to our topology. So it means 65002, then this is the AS path I have configured for the BGP 65004. So right, so then it's coming to me only 3. Right now there is another path which is via 10.0.30.2.7t, which is from 65, that is from ISP number 2. So if you see here, 65003 is advertising, so leaf 5 is advertising that to leaf 3. So leaf 3 has two paths now to reach to the 30.30./32. One is via leaf 5, another is via leaf 4, and another path is via leaf 3. So it has total 3 paths. So let me clear this all thing. Okay. Yeah. So if leaf 3, yeah. Okay. So if leaf 3 wants to reach to 30.30.30/32, one is path is directly connected, one is via leaf 4, and one is via leaf 5. Right. But that is 30.30.30/32 right here. Okay. Now let's see leaf 3 is installing which path and why. Okay, so leaf 3 is installing, you see here, that cursor here, this one is my best path. You see, that is my best path. Now one is star is valid, it is my best path. And then E, so E is external. Why external? Because that is advertised by my external. And you see the other path, right, which is advertised by leaf 4 and leaf 5, I am putting I flag. You see I. Now why I? Because that's the internal flag. Internal meaning is that those are advertised by internal ACI IBGP neighbor to me, right? So that's why I'm installing this. So now let's see on the leaf 5. Now on the leaf 5, I'm doing show IPBGP. I'll see those three paths, right? One is via 32.67, which is 32.67. So leaf 5 is a if I want to reach to 30 dot, so that's a path. That's a path. Another will be via through leaf 4. Another will be via leaf 5. That is external. So leaf 5 is again installing the external path, which having more preference, right? Now let's see in the BGP path algorithm where it stands, right? So if I go to the BGP path selection algorithm, right? Now next hop, it should be reachable, yes. So next hop is reachable. Did I configure wait anywhere? No, right? So you see here the wait attribute, right? 0.0, it's all 0, it's all 0, right? Similarly in the leaf 3, it's all 0, right? So it means all the three paths are same. Right. So next is local preference. Did I configure any local preference? No, right? So you see local preference, it's 0, right? Now other local preference, you see 100 here, right? And you may ask, uh, like, why it's not giving preference to this 30.70, right? Why 30.70? Where is 30.70? So I'm checking on leaf 3, 30.70. So guys, remember this always, in the BGP, whenever you installing some, if you are advertising some routes through IBGP, it will take by default 100 local preference. Okay, so whenever it means leave 5, when it distributes some routes to, or send a BGP update to the leave 3, right? So it will put a local preference 100. That is by default. Okay. Now next one is local preference. No, locally oriented route. No, it's not locally, it's external to me. How I know? That is external to me, because that's I flag here, which means that is coming from the IGP. And moreover, the next hop is, it's not me, right? So if you see 1.1.1, that is a locally oriented, so I'll give more preference to this always. If you see this 0.0.0, it means that is locally originated by me, and you will see the weight is more always. But in this case, those all are advertised external to me, right? So AS path length, smaller length is preferred. No, right? So all the AS path length is 2 for all the 3 routes. Now next come to the origin prefer. Or in all the 3, it is I, right? It is I here. Now next is MED value, right? MED smaller is preferred. Did I configure anywhere MED? No, right? And how I can verify? What I can do, show IP BGP. I can put this prefix here and VRF, and under that VRF. So you see MED is not set. MED is not set. MED is not set. So I have not set any MED. So it means MED value is by default value, which is 0. The next hop is neighbor type prefer eBGP over IBGP. So that's where it is putting that. So by looking into this command, show IPBGP here, right? This is I flag here, right? This is I flag. I means the internal, that is IBGP, right? IBGP. So it means I'll give more preference to eBGP neighbor over the ISP. So similarly, you will see on the leaf 5, it is giving more preference to 10.30.12, right? I hope it's making, you are all with me, and that's making some, you're basically understanding what we are doing here. Okay, so now let's jump here. Now leaf 5 here. Now meaning is 30.30.30/32. It is reaching via this path, and leaf 3 is reaching via this path. Now if any server 1 wants to reach to 30.30.1, let's see which path it is preferring. Okay, which path it is preferring. So in the leaf 3, I have VRF, which is VRF server here, right? So if I do show IP route to 30.30.30.30/32, and I'll put, sorry, VRF, right? So it is say next hop. If I want to reach to this, it's via 10.1.12.2, which is BGP external tab, which is routed by this. So it meaning is that if leaf 3 wants to reach to, so it will be directly via this path. Now for some reason I want that server 1 wants to reach to this 30.30./32. It takes path via leaf 5. Okay, so in its routing table, leaf 3 advertise that the next hop, this 30.30 is reachable via 32.70. It's not via 10.2, right? So what I can do, I can say, when this Nexus 9K host 1 is advertising this 30.30.2, 30.30.30/32 routes to me, I will add more local preference, or I can add more weight value, and then it will give more preference to this one, 30.30/32. Okay, so let's do this one. Okay, so what for that, what I need to use, I'll use the route map. So route map, if you want to use it, go to the tenant, go to the specific tenant, go to the policy protocol. Now you can go route map for route control. I'll create a one route map for route control. So I will say prefix is 30.30.30.30. Now slash 32. For some reason it will not take slash 30. So I'll put this prefix 30. Okay. Now order value is 0, meaning it's just like a prefix list, starting from 0, 1, 2, like that. Okay. So I'll give some name like prefix 30 on leaf 34 on leaf 34. Okay, so actions deny permit. So if you want to match it, it will already. Now I need to put the match rule. Okay, so I'll create a match rule. So I will say prefix 30 match. Okay, now you can match with the community, you can match with the IP. So in this case we'll use the IP. So I'll use the specific. Okay, 30 slash 32. Why? Because that's the one I'm receiving. 32 slash 32. Okay, so that's why I'm putting the specific route here. So I will submit it. Now set rule. So what you match with that prefix. Now you want to set the rule. Now I'll say local preference. Okay, local preference for prefix 30. So I'll set a set preference. So by default it is 100. So I'll say 200. Now finish. Actually, guys, that will be leaf 5, right? Because it will not leaf 3, 4. Sorry. And so I want to put more preference to leaf 5, so that when leaf 5 are advertising the route to leaf 3 and leaf 3 will say, okay, more preference is coming, local preference is coming. So that I will install. Okay, so I need to put on the leaf 5. It's just a name, I'm changing it. So earlier I used leaf 3, 4. So I'm here using leaf 5. Okay, I matched 32. Rest will be the same. So I'm matching with the this specific sub prefix list, and in the match rule I am setting the preference to 200. Okay, now okay, prefix 30 is really 5 sub. Now I created the route map. Now I need to implement this route map to my L L3 out. So if I go networking here, L3 out. Now, so this is one I created, BGP L5, BGP L3, L4. So meaning is that similar, BGP only 5, BGP only L3 and L4. So you can use anything. So on the BGP leaf 5, I'll go under the logical node profile, interface profile, peer connectivity profile. Okay, that's where I'll I'll put that prefix. So that's my route import policy. Meaning is that whenever I'm importing some route from here, I'll put more weight, more local preference to those route. Now if I go on the leaf 5 right now, so if I do show IP BGP, this 3230 is that it's coming to me via default local preference. So meaning is that there is no local preference here, because that's the BGP membership. So there is no local preference I am putting here. Right now, as soon as I click update here, for this direction, let me delete this one. Okay, let me put that again. This one, update. Yeah, I think I clicked 2 times update there. No, so now if I check show IP BGP VRF for this one, you see this one 10.3.12 is coming with local preference 200. Now this leaf 5, leaf 5 will advertise to leaf 3 and leaf 4 via the IBGP membership. Now as we learn that the local preference in this, right, in this uh, uh, local preference is while not discretionary, so it will be updated to the other BGP neighbor. Okay, so now if I go on the leaf 3, um, okay, so if I go on a leaf 3 and if I do show IP BGP VRF, this one, you see, I'm giving more preference to the internal IBGP neighbor over the external. Why? Because the local preference is 200. Now, if I do a show IP route 30.22 VRF server, you see 30.2.70. So it meaning is that if this server wants to reach to 30.30.30, the path will be via leaf 5. Okay, so on a leaf 5, if you want to see the route map, right, I can see that route map. Okay, so the command is show BGP IPv4 unicast neighbor. So my neighbor is this one, right? Under VRF, VRF is this one. Okay, so that's a so I can grab with map command. Okay, so when I'm grabbing with map, so it's inbound and outbound. Okay, so that's my route map which I have configured. So route map and this one. So you see this prefix list is configured, which let's see this prefix list. Okay, show prefix show IP prefix list. Okay, you see, so IP prefix list is this one, has one entry which is 32.32.30/32. Now what I'm doing for that entry, I'm setting the local preference to 200. Okay, so I'm setting the local preference to 200. Uh, now if you want to but the problem here is, guys, if you see, earlier I was advertising 31.31.31/32 to the leaf 5, but now if I'm checking on the leaf 5, right, where it is, see, 31.31.31 is there, but you see X here. So X means it's deleted. It's not present here. Now if I think that will be go away now. If I check show IP BGP VRF, so that 31.31.31 is not there. Now why it's not there? Why it's not there? Any idea? So it's not there because you have configured the local preference for 32.31, but what about this 31.31.31? You have not specified anything, right? So by default it will not put that into the BGP route. It's advertising it, but I'll not put that into the my BGP table. Why? Because there's no route map configured for this, right? There's no route map configured because right now if I see this one, there's only one sequence, 32.32/32. Now what I need to do, under the same prefix list here, I'll put the order 1 and I will say all remaining. Okay, now I don't want to set any rule for the other remaining routes, but I want to match it. So match it with whom? Match, I will say match all. Now in the prefix list I will put 0.0.0/0. Now if I click OK here, so it will match only this one, but I need to put the aggregate, meaning is that start from prefix 0 to the prefix, so it means all the route. Now if I don't select here, it will always select it's kind of default route. So meaning is if it is advertising the default route, I will allow it, otherwise I will not allow it. So remember, guys, we need to select this aggregate flag here as well. Okay, so now I click OK here. Now submit. Once I submit, update and submit. Now let's see on the leaf 5. If I do show IP BGP, see 31, but there is no local preference for this, right? So I hope, guys, you like this BGP path attributes. So we haven't discussed that much into the other path attributes because I want to cover that into the part 2 of this BGP path selection algorithm. Thank you all. Thank you for watching. Have a great day. Bye.